become a marine certified electrician, several credentials, classes, and types of experience are generally required. Firstly, National Electrical Code, or NEC, certifications are essential. These typically include NEC Code and Safety, NEC Electrical Calculations, NEC Electrical Equipment, and NEC Electrical Wiring. Secondly, additional certifications can significantly enhance qualifications. These may include ABYC, or American Boat and Yacht Council, Electrical Certification, and NMMA, or National Marine Manufacturers Association Marine Electrical Certification. A United States Coast Guard license may also be necessary for electrician work on commercial vessels. Thirdly, formal education and training are important. A high school diploma or equivalent is generally a minimum requirement. An associate's degree or certificate in electrical technology is highly recommended. Completing an apprenticeship program, typically lasting 4 years, provides valuable hands-on experience. Fourthly, practical experience is crucial. 2 to 4 years of work experience in electrical construction or maintenance is generally expected. Specific experience in marine electrical systems is highly preferred. Fifthly, specialized knowledge and skills are necessary. This includes a thorough understanding of the NEC Marine Supplement. Knowledge of marine electrical systems, components, and wiring is essential. Experience in troubleshooting and repairing marine electrical problems is also important. The ability to work in confined spaces on boats is often required. Strong attention to detail and safety is paramount. Furthermore, there are optional but recommended qualifications. NFPA 79 Electrical Standard for Marinas and Boatyards provides valuable knowledge. IMO, or International Maritime Organization, standards for electrical installations on ships may also be beneficial. The steps to become a marine certified electrician generally include the following. 1. Obtain the necessary NEC certifications. 2. Consider obtaining an ABYC or NMMA electrical certification. 3. Complete an apprenticeship program or gain relevant experience in marine electrical systems. 4. Pass the U.S. Coast Guard license exam, if required for the specific type of work. 5. Stay up to date on industry best practices and regulations. The NEC forms the foundation for safe electrical installations, covering general requirements and specific rules for various occupancies and equipment. The NEC Code and Safety certification demonstrates a fundamental understanding of these principles. The NEC Electrical Calculations certification covers the methods for calculating circuit loads, conductor sizes, and overcurrent protection, ensuring systems are properly sized and safe. A NEC Electrical Equipment certification focuses on the proper installation and application of various electrical equipment, such as transformers, generators, and motors. The NEC Electrical Wiring certification covers the specific requirements for wiring methods and materials, ensuring safe and compliant installations. ABYC electrical certification demonstrates expertise in the specific standards and recommended practices for electrical systems on boats. ABYC standards cover a wide range of topics, including wiring, overcurrent protection, battery systems, and shore power connections. NMMA Marine Electrical Certification shows competency in the standards and guidelines developed by the National Marine Manufacturers Association for Marine Electrical Systems. NMMA certification often involves an understanding of ABYC standards as well, as the two organizations work closely together. A U.S. Coast Guard license may be required for electricians working on inspected commercial vessels, such as passenger ferries or cargo ships. The specific requirements for Coast Guard licensing vary depending on the type and size of vessel. An associate's degree or certificate in electrical technology provides a solid theoretical foundation in electrical principles. This can include courses in circuit theory, electrical machines, and power electronics. An apprenticeship program offers on-the-job training under the supervision of experienced electricians. This allows apprentices to develop practical skills and gain hands-on experience in a variety of electrical tasks. 2 to 4 years of experience in electrical construction or maintenance provides a broad understanding of electrical systems and installation techniques. Specific experience in marine electrical systems is highly valuable, as these systems have unique requirements due to the marine environment. Understanding the NEC Marine Supplement is essential for marine electricians, as it contains specific rules and requirements that apply to electrical installations on boats and other marine vessels. Knowledge of marine electrical systems, components, and wiring is crucial, as these systems must be designed and installed to withstand the harsh marine environment. Experience in troubleshooting and repairing marine electrical problems is highly valued, as these problems can be complex and require specialized knowledge to diagnose and fix. The ability to work in confined spaces on boats is often necessary, as electrical equipment is frequently located in tight and difficult to access areas. Strong attention to detail and safety is paramount, as electrical work on boats can be hazardous due to the presence of water and flammable materials. NFPA 79, Electrical Standard for Industrial Machinery, provides guidance on the safe design and installation of electrical systems on industrial equipment, which can be relevant to some marine applications. IMO standards for electrical installations on ships provide international guidelines for the safe and reliable operation of electrical systems on ships. These standards cover a wide range of topics, including power generation, distribution, and lighting. The NEC, or National Electrical Code, is a comprehensive set of standards that govern the safe installation of electrical wiring and equipment in the United States. It is updated every 3 years by the National Fire Protection Association, or NFPA. The NEC is widely adopted by states and local jurisdictions as the basis for their electrical codes. The code covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It also includes specific requirements for various occupancies, such as residential, commercial, and industrial buildings. The NEC is organized into chapters, articles, and sections. Chapter 1 covers general requirements, such as definitions, scope, and administration. Chapters 2 through 7 cover specific aspects of electrical installations, such as wiring and protection, wiring methods and materials, equipment for general use, special occupancies, special equipment, and special conditions. Chapter 8 covers communications systems, such as telephone, data, and cable television. Chapter 9 contains tables and examples to assist in applying the code. The NEC is a complex and detailed document, but it is essential for anyone involved in electrical work. Electricians, contractors, inspectors, and engineers all rely on the NEC to ensure safe and compliant electrical installations. The NEC is not a design manual, but it provides the minimum requirements for safe electrical installations. Designers and installers must exercise good engineering judgment and follow industry best practices to ensure that electrical systems are reliable and efficient. The NEC is constantly evolving to keep pace with new technologies and changing safety concerns. The NFPA publishes proposed changes to the NEC for public comment, and these comments are considered by the code-making panels before the final version of the code is issued. Staying up to date on the latest edition of the NEC is essential for anyone involved in electrical work. There are many resources available to help people learn about the NEC, including training courses, seminars, and publications. The NFPA also offers a variety of resources, including the NEC Handbook and the NEC Analysis of Changes. The ABYC, or American Boat and Yacht Council, is a non-profit organization that develops safety standards for the design, construction, and repair of boats. ABYC standards are widely recognized and used by boat manufacturers, repair facilities, and surveyors. ABYC standards cover a wide range of topics, including hull construction, electrical systems, plumbing systems, and fuel systems. The standards are developed by technical committees made up of industry experts, including engineers, manufacturers, and surveyors. ABYC standards are updated regularly to reflect new technologies and changing safety concerns. ABYC offers a variety of certification programs for marine technicians, including electrical, diesel, and gasoline engine certifications. These certifications demonstrate that technicians have the knowledge and skills necessary to perform their job safely and effectively. ABYC also offers a variety of training courses and workshops to help marine technicians stay up to date on the latest technologies and best practices. The NMMA, or National Marine Manufacturers Association, is a trade association that represents both manufacturers and other marine industry companies. NMMA develops standards and certification programs for boats and marine equipment. NMMA certification programs are designed to ensure that boats and equipment meet certain safety and performance standards. NMMA also works to promote boating safety and to advocate for the marine industry. The U.S. Coast Guard is the federal agency responsible for enforcing maritime laws and regulations, including those related to boat safety. The Coast Guard also licenses and regulates mariners, including those who work on commercial vessels. The Coast Guard requires certain mariners to hold a license or certificate in order to work on commercial vessels. The requirements for obtaining a license or certificate vary depending on the type and size of vessel and the position held. The Coast Guard also conducts inspections of commercial vessels to ensure that they are in compliance with safety regulations. An electrical apprenticeship is a structured training program that combines on-the-job training with classroom instruction. Apprenticeships typically last 4 years and are sponsored by employers or trade unions. During an apprenticeship, apprentices learn the skills and knowledge necessary to become qualified electricians. Apprentices work under the supervision of experienced electricians and gradually take on more responsibility as they progress through the program. Apprenticeships provide a valuable opportunity to gain hands-on experience and to learn from experienced professionals. Completing an electrical apprenticeship is often a requirement for obtaining a journeyman electrician license. A journeyman electrician is a licensed electrician who is qualified to work independently. Journeyman electricians have completed an apprenticeship or have equivalent experience and have passed a licensing exam. A master electrician is a licensed electrician who has extensive experience and knowledge of electrical systems. Master electricians are often responsible for designing and overseeing electrical projects. Master electricians typically have several years of experience as a journeyman electrician and have passed a master electrician exam. Continuing education is important for electricians to stay up to date on the latest technologies and code requirements. Many states and local jurisdictions require electricians to complete continuing education courses in order to renew their licenses. Continuing education courses cover a wide range of topics, including new technologies, code changes, and safety practices. Staying up to date on the latest technologies and code requirements is essential for electricians to provide safe and reliable electrical services. Marine electrical systems are subject to unique environmental conditions such as exposure to salt water, humidity, and vibration. These conditions can accelerate corrosion and cause electrical failures. Therefore, marine electrical systems must be designed and installed to withstand these harsh conditions. Marine electrical systems typically use corrosion-resistant materials such as copper, brass, and stainless steel. Wiring is often tinned to prevent corrosion. Electrical connections are sealed to prevent moisture from entering. Marine electrical systems also require special overcurrent protection devices to protect against short circuits and overloads. These devices must be able to withstand the high currents that can occur in marine environments. Grounding is also important in marine electrical systems to prevent electrical shock. The grounding system must be designed to provide a low impedance path for fault currents to return to the source. Marine electrical systems must also comply with applicable regulations and standards such as those developed by the ABYC, NMMA, and U.S. Coast Guard. These regulations and standards cover a wide range of topics, including wiring, overcurrent protection, grounding, and equipment installation. Complying with these regulations and standards is essential for ensuring the safety of marine electrical systems. Troubleshooting marine electrical problems can be challenging due to the complex nature of these systems and the harsh environmental conditions. A systematic approach is essential for effectively diagnosing and repairing marine electrical problems. The first step in troubleshooting is to gather information about the problem. This includes talking to the boat owner or operator to find out what happened, when it happened, and under what conditions it happened. The next step is to visually inspect the electrical system for any obvious signs of damage, such as broken wires, corroded connections, or burned components. After the visual inspection, the next step is to use a multimeter to test the electrical circuits. This can help to identify open circuits, short circuits, and voltage drops. Once the problem has been identified, the next step is to repair the electrical system. This may involve replacing damaged wires, cleaning corroded connections, or replacing faulty components. After the repairs have been completed, the electrical system should be tested to ensure that it is working properly. This includes testing the voltage, current, and resistance of the circuits. Marine electricians must have a thorough understanding of electrical principles, marine electrical systems, and troubleshooting techniques. They must also be able to work safely in confined spaces and in harsh environmental conditions. Marine electricians play a vital role in ensuring the safety and reliability of marine electrical systems. They help to keep boats running smoothly and to protect boaters from electrical hazards.